Hello students, welcome back to another math lesson. Today we're talking about solving problems with more than one triangle. Just a reminder that we've got our three trig ratios, sine, cosine, and tangent. And if you can remember the SOHCAHTOA, whenever you're trying to figure out which ratio to use. And we've also got the Pythagorean theorem. So let's look at a quick review question. It's math on the job. It's about a surveyor using some equipment to find distances between locations. And it's always a good idea to draw diagrams, so let's do that. Something like this. And we've got 68 degrees at the bottom. Pin 1, 2, and pin 3. This is 40. This distance is labeled as D2, so this would be D1 over here. So we want to find out what D1 and D2 are. So we have to figure out which trig ratio we want to use. So for D1, and we're always going to reference this angle since that's the one given. D1 is the adjacent side, and we know the hypotenuse, so that's the cosine function. So cosine 68 equals D1 over 40. Okay, and you're going to find the cosine of 68, and you're going to multiply it by 40. This is a multiplication question, so it would look like 40 cos 68 equals 1. And remember, you're not multiplying by 68. You have to find the cosine of 68, multiply it by 40, and you'll get 14.98 equals D1. And that would be meters. Okay, and now we're going to find D2. And from the 68 reference angle here, straight across is D2, so that's the opposite side, and we know the hypotenuse, so this is the sine function. Sine of 68 equals D2 over 40. Okay, and we're going to, again, multiply, so 40 times sine 68 equals D2, and sine of 68 times the 40 ends up being 37.1 meters is the distance between pin 2 and pin 3, which is D2. Okay, let's move on now to example 1. We're going to start needing to use two trig ratios in order to solve one question. Okay, so let's look at this one. While on vacation, a couple decides to climb a cliff overlooking a river. In planning ahead for the climb, they hire a surveyor to take some measurements to calculate the height of the cliff. From a point P, which is down here, on the shore directly across from the river, the angle of elevation to the top of the cliff is 43 degrees. Okay, so here's your angle of elevation to the top of the cliff. And from a point S over here, 30 meters down the river, the angle of elevation, or the angle to point T, is 68 degrees. So we have this information. Now using it, let's find the height of the cliff. And the height of the cliff, I'm going to call H. Okay. Now in order to find H, in this triangle, PRT, I only have two pieces of information. I need one more piece of information. I've got the 43, I've got the unknown, so I need the length of either the hypotenuse or this side here. So if I look at this triangle here, I've got two pieces of information. If I call this my unknown, x, I've got a triangle that I can solve here for x because I've got enough information. So that's so from this angle, the opposite side and the adjacent side are involved. So that's the tangent function. So tangent of 68 is equal to the opposite side over the adjacent side, 30. So I'm going to solve this as a multiplication question because the unknown is in the numerator. 30 times tangent of 68, 30 tan 68 equals x. When you do that multiplication, you get x equals 74.3 meters. So right here is 74.3. Okay, so now I've got enough information in this triangle to help me solve for the height of the cliff. So from 43 now, I am looking for the opposite side and I know the adjacent side. So that's another tangent function. So tan 43 equals opposite, this time it's h, the height of the cliff, over what we just calculated, 74.3. Again, we're going to multiply the tangent 43 with the 74.3, and then you do that multiplication, you get 69.2 meters as the height of the cliff. 69.2 meters. Okay, so we had to use two trig ratios in order to solve for the height of the cliff. Let's try this next piece. It says, if a zip line was built from the top of the cliff to point P, what would be its slope? Okay, so what we need is the slope of this line here, because there's the zip line. Okay, now if you recall from one of our previous chapters, slope is also equal to tangent. So if I take the tangent of 43, I will find out what the slope is. And the tangent of 43 is 0.93. So the slope of that line is 0.93. So remember, slope is the steepness of that line, not its length. Okay, let's go on. We'll do one more example, and then that'll be the end of today's lesson. So example 2, building is 32 meters tall. At one position from the base of the building, the angle of elevation to the top of the building is 81 degrees. At the point 4 meters further away, what is the angle of elevation? So always draw yourself a picture. So I'm going to draw, okay, here's the edge of the building, talking about skyscraper, and then from some point at the base on the ground, I've got 81 degrees. Okay. The building is 32 meters, that's given. And then it says at another point, 4 meters away. So this line here is 4 meters from this point to this point. 4 meters away, they want to know what this angle is. Okay? So in order to do that, I'm going to find what this value is here. So from the base of this wire to the edge of the building. Let's find that. So from the reference angle of 81, I know the opposite side and I'm looking for the adjacent side. So that's a tangent function. Tangent of 81 equals opposite 32 over the adjacent x. Now remember, because the unknown is in the denominator, this is a divide question. So x is equal to 32 divided by tangent of 81. Okay, so find the tangent of 81 and then divide it into 32. So 32 divided by tangent of 81, and that equals 5.07 meters. Okay, so this is 5.07. Next, I want to find this angle here. So in order to do that, I'm going to need this whole length here. Okay, and I know that this is 4, this is 5.07, so if I add those two together, I get 9.07, so that's this distance. I'm going to use that in this big triangle here in order to solve for this unknown angle. So this side is 32, this side is 9.07, opposite and adjacent, that's again the tangent. So tangent, now I don't know what the angle is, so I'll call it theta, is equal to opposite, 32, over adjacent, which is 9.07. So whenever we're looking for the angle, it's the inverse tangent, inverse of the function. So theta is equal to inverse tan and we're going to divide the 32 by the 9.07, and that equals 3.53. And then I'll take the inverse tangent of that, and I get theta is equal to 74.2 degrees. So this angle in here is 74 degrees. 74. Okay, again, we had to solve two different triangles in order to find the information that we were looking for. So I will continue this lesson on the next day. Thank you. Take care.